whoa. Thank you very much. First, need to clean up one misconception. This is not Nerd Disco. I'm not Tim. Nerd Disco 2.0, as Malte said earlier, is actually something that Tim Piotrowski made, but he inspired me quite a lot. So yeah, let's go. I'm Martin. I come from the beautiful city of Hamburg, and I go by the name. I go by the name Useful Think anywhere on the internet, so feel free to contact me if you have any questions later or anything. So I'm going to talk a lot about homemade electronics and things that look like bombs. I did actually start studying electrical engineering, then switched over to computer engineering. So being a JavaScript developer today is more or less an accident that happened 13 years ago or something. But yeah, I pretty much love JavaScript, and nowadays I'm writing everything I do either in JavaScript or in Bash. So yeah, that's a way to go. And yeah, I love this field of homemade electronics, and especially since Arduino, Raspberry Pi, and all that made it so accessible and affordable. So at last year's JSConf, there were several really inspiring talks for me, and especially that guy, which is Tim, which made Nerd Disco. And I was then finally like, yeah, I totally need to get back to doing hardware stuff and all that. And yeah, I started to buy a soldering iron, I started to buy some LEDs, and yeah, that quickly escalated, and now I'm having this at home, which is my electronics lab, which my girlfriend still calls our dinner table. So, what is this all about? I want to show you some of my recent projects. All of them have to do something with lighting. And yeah, I'm really fascinated about all this lighting topic and all that. So yeah, I will show you how I use web technology in these electronics projects in order to control them, in order to do different things with them. So, first of all, it was, for me, it was about having fun with JavaScript, having fun with electronics, all that stuff with soldering irons, and yeah, it's fun for me. And lastly, and this is also inspired by last year's JSConf, Brad Bowles made a great talk that you should definitely watch if you haven't already. About the usefulness of uselessness. And yeah, I had a project for the last 2 months that doesn't need to be anything. It doesn't need to be completed. It doesn't need to be, and yeah, it didn't even have any feature schedule or something. So yeah, I was just like exploring this topic and yeah, see how we went. The first thing I'm going to show you is this is a power strip I made, and I know what it looks like, but yeah, these boxes are actually the cheapest thing I can buy to put my electronics in there. And yeah, when I was young, 20 years ago or something, I had so many lights in my room, and it was like the main switch at the door didn't even work, but I had to travel around my whole room to switch here a light on and there a light on, and had some switches there, and everything was somehow inaccessible. And I wanted to change this, so this thing here is actually Wi-Fi controlled. So, in the inside, you see there are 3 relays that do the actual switching and handling all this high mains power things. Then there is some stuff around that, and most importantly, this ESP8266 module, which is a tiny Wi-Fi module, which is used to control all things. And yeah, there's a USB charger in there, which I ripped from some wall plug thing. And yeah, pretty much all improvised, but definitely really cheap. So, one warning beforehand. Please do not do that at home. You need to know what you're doing when you're handling mains voltage and all that. So let's go on to things that don't want to kill you, which is this So this ESP8266 module, it is an incredible feat of electronics. This is just €2 a piece, and it has really a decent CPU in there. And yeah, for just €2, it is actually some kind of affordable electronic that can put anywhere and just leave it there. And if I need another one, I buy another one. It doesn't make sense for Raspberry Pis or Tessels or anything that costs around €30 or something. So this thing, there is a Lua interpreter running on there. Unfortunately, there is not yet a JavaScript interpreter, but maybe some people from the IoT.js and duct tape projects are here. So yes, please make this happen. They are developing JavaScript engines that could run on these small devices. So how does this look like? Basically, this Node MCU, it is modeled after Node, actually. So all the APIs are immediately familiar, and yeah. So on the left-hand side, you see how can we connect to some Wi-Fi network, which is just setting the SSID and the passphrase, and then calling connect. So this is it. And on the right-hand side, this is how one could handle HTTP requests there. And yeah, pretty much that's it. It didn't have an HTTP stack, but I wrote a quick implementation, so you don't need to know any Lua to use this. So, and now, quick prayer to the demo gods that the Wi-Fi is working. So where's the mouse? Ah, there is it. Okay. So I can now, hopefully, just switch this on. All right. There's such a great relief. Wi-Fi is working. It is it's not the conference Wi-Fi. It's my phone's hotspot here, which communicates with all these devices. Yeah, I was pretty unsure if this would actually work. So yeah, I have two more switches here, but no, they are not connected to anything. Don't worry. So. We're going to talk a lot about lighting, and so we are going to talk about LEDs because everything else is mains voltage, wants to kill you, and so LEDs are really the modern way to produce light. So I built these two things over there, and I have just such a demo button here. Ah, yes, all right, that works. So the right one, left from your side, this is an early prototype I built. It has only a white LED, and the other one is more sophisticated with full color LEDs and a little bit more electronics in there. But let's first look at the small one. I threw together with my Arduino and some components this thing, which I will now use to show you how dimming of LEDs actually works. So it's really just switching it on and off again. So if I turn this knob here, you will see that the speed, the frequency with which it is switching on and off is increasing and increasing and increasing, and it flickers and flickers and flickers, and suddenly you will just see its half brightness. And now I can go ahead and just move it further to reduce the duty cycle, so yeah, it fades out. So this is basically how LEDs are dimmed, and the same goes for RGB LEDs, where you just do this 3 times, which is exactly what is happening in the second cube, which looks like this from the inside. And yeah, I have the very same Wi-Fi module there, and all the rest is basically just power supply for all these beefy 12-watt LEDs. So yes, to communicate with this thing, I tried HTTP, but these tiny Wi-Fi chips quickly died of memory exhaustion, so I had to use a different protocol to talk to them. This is called Open Pixel Control. This is actually something that other applications also use, so not a bad idea to adopt open protocols if you do something like this. And yeah, it's really simple. You have a channel, you have a command, you give them a length, in this case 9 bytes, and then there are 9 bytes of color data. So RGB, and if we just do this, and I implemented this as a node stream, I can now monopixel.jsconf, that is a DNS name of that thing, and I have this demo switch here, and hopefully, yeah. So what you can see here is just a loop that is running at 20 frames per second. And it just updates the color and sends a data packet with the color to this small cube there. Oh. I can't dim the lights from here. So anyway, I hope you thought. So what we can also do is just control it directly. So I have this color chooser here. It's a bit weird with mouse position, but yeah. And this is just out of my presentation over a WebSocket to a server, which formats the OPC messages and sends them to the cube, and that's it, basically. So what about more LEDs? So this is something. Who was there last year when Tim Piotrowski held his Nerd Disco talk? Oh, quite a lot. All right. So this is exactly the type of LED he was using. So this was also the first thing I bought when I came home after last year's JSConf. And so these tiny things are called WS2812, and they are also called Neopixel. If you search them online, you will find them by that name. Also, great tutorials at adafruit.com and all that. So they are really tiny LEDs, which are fully independently addressable. So I can just send each of the LEDs in the strip can send their own color value. So I can do amazing things with it. So the first thing was I didn't have a Tesla like Tim had for this presentation. I just had my Raspberry, and I was researching, yeah, what can I do if I just want to control them from a Raspberry Pi? The thing was, there is a library written by Jeremy Garth, and he does all this complicated stuff that needs to be done in order to convince the Raspberry to send this data signal the LEDs need. And so this was pretty easy. Just taking this library worked. And I wrote a Node.js add-on for this. So I just wrapped all those libraries functions into a Node add-on written in C++. I don't know C++. It was quite hard for me to do that. But yeah, it's basically just glue code, handling arguments and all that. And I actually learned quite a lot about V8 doing this. So this is what the interface of this module looks like. So I have an init function, and I need to tell him how many LEDs are there, so he can get the timing right. And then I have a render function. The render function just takes a typed array. Thought it was a good idea at that time. And finally, there's a reset function in order to let the CPU release all this stuff that it allocated. So in order to test this, we come back to the rainbow now. We do it just 100 times. And this is what you see right there. So so it's basically the same example you saw earlier. It's just added the initialization call, and then we go through a loop and set the rainbow colors with a slight offset so you can see a bit of animation. But in the end, this is just an array of numbers. And yeah, how do you even draw a line in an array of numbers? So I thought, yeah, maybe web technology has something for us. And indeed it has. So you can just take a 10 by 10 pixels canvas element. You can draw to the context anything you want. And finally, just get image data and convert this canvas pixel array back into the uint32 array that we need to drive the LEDs. So we can just, with these few lines of code, we read a file, which is a JavaScript logo, and we just say context draw image, and I have this demo button here, and there you are. So, and it doesn't stop there, of course, because we can also do, well, kind of GIFs. This is something my girlfriend built for me today. She's way better in Photoshop than me. Does it? Yeah, it animates there. All right, so and the other thing is, the only practical use of the thing is, it's the first 8-bit fireplace. And it actually works. If we are having a chilled evening at our home, we can just put this on and have feeling of a fire. Well, anyway, did not stop there either. So you can just write the code right away. So I built this, which is just some editor here, and I can now maybe uncomment this line. And so what you see there is a canvas that is rendered in the browser, and the pixel data is sent over a WebSocket to my PC, and it's sent over Wi-Fi to the Raspberry, and quite elaborate, but yeah. I like that. I can't edit it here, but I can just change the color, for instance, or yeah, pretty much anything. I will try to set it up somewhere around here for the party if anybody wants to hack. I would like to see that. So, moving on, the next topic, actually, is professional lighting. Because, yeah, this is, I thought it was like, maybe the people back there, they can't barely see what I'm doing here, and it's not really immersive that way. So, when I got this confirmation that I will be speaking here, I was like, maybe I just invest a little bit, and I bought this little thing here, which is a moving head spotlight. So it was the cheapest I could find on China. But it actually works and helped me explore a little bit how all this professional lighting stuff works. I have to admit, there is a little bit of background I have in the topic. I worked as a lighting and stage technician during my school time for around 6 years or something. Yeah, I picked up quite a bit of knowledge about how all this works, and so this was the main driver of this idea, just to combine the things I did earlier with the things I do today and see where this ends up in. So, the fun thing about professional lighting is that actually there is only one protocol. There is every device you can buy will speak this DMX 512 protocol, and it's so simple that it's really just 512 channels, and each channel is just a byte. So it resends its old state at around 40 frames per second or something, depending on hardware. And yeah, every device in there has a fixed address, so there's really nothing complicated on there. So I built an interface for this. This is this tiny box here, and consists basically of an Arduino, which I had lying around, and a custom board, which does the electric part of this protocol. And yeah, of course, if I have this interface which speaks USB, then I can just go ahead and go on and write some node code. In this case, I use a serial port module, and open some serial port connection, and finally I have this DMX serial driver which converts a raw data array into the format that is spoken with Arduino, which is a bit more space saving than just sending 512 bytes over and over again. So yeah, the basic procedure would be I set up this buffer and then I set the values and finally send this buffer away. So setting values is something that was originally DMX was thought to be used just for dimming of single lamps. When it was invented, there were no moving head spotlights or anything. So the vendors all started to define their own channel mappings and how they would interpret the channels. So basically, it is like this. Every device has a fixed starting address. In this case, it is 421 or something. And from there on, you have to refer to the data sheet of this device. You can see that in the background, where it says channel 1 and 2 are pan, and channel 3 and 4 are tilt, which is the 2 rotation axes. And yeah, they're just using 2 channels to have 16-bit precision. And then there are several different features. Sometimes there are multiple features on the same channel, and yeah, it's all kind of weird. But basically, if I run this together with from the previous slide, you will at least see it lights up. So it's in 0 position, and it lights up. So that's so far so good. And once again, we end up with an array of numbers. So yeah, let's try to find an abstraction or how to handle these numbers in a more meaningful way. And I thought about how to do this, and I ended up with using define property all the way along, and just built my objects where I can access just like pan and tilt values, or the dimmer or color values, and through the magic of define property, I can also use CSS color values, and they get converted to RGB or CMY or whatever the device needs. So lastly, this on the left-hand side can now be written as that. And there you can see how these parameters are defined. I have pan, tilt, color, and dimmer, and I can assign values to them. So now I built something which I call the DMX output, which just manages this creation of the buffers and handles sending of data periodically. And yeah, this is in this case just running at 20 frames per second, which is the number that you pass to the start function. And then there's request DMX frame. I like picking names that somehow correspond to things that we know from web development. So you have this loop, and if I now start this, we'll have a working, moving head spotlight, which will hopefully not shine you in the eye. So yes, so far so good. Now I talked to Malte, and finally I was actually at this very place 2 weeks ago. And so yeah, let's see how we can scale this up, because so what you can see here is the actual lighting schedule, which is just the numbers of some spotlights and lamps that are all around the place, and there are the green ones and the blue ones, which I am allowed to control right now. So in order to handle more than just this single device, I built something I call a device group, and I just used all the same defined property magic once again. And so each group acts as if it were a device, so you don't see a difference if you're handling a group or a device. I wish the DOM was worked that way. So anyway, I can now just define a group of devices, and I can put some values on the whole group. And I built the registry. The registry is basically just some database where all the settings and fixture types and all that of all these lamps here in the room are stored. So the basic interface for this is just a select function, and the select function will return a device group, and each group will have a set of all properties of all devices, so I can easily access anything. So, let's do that again. Now with all devices. Hopefully this works. So once again, there's just an animation loop, and I'm using just a sign of the time for defining the tilt angle the devices are in, and so we get a nice smooth movement. But yes, there's even more. And yeah, this is just, I had to write a function for each light setting that I want to do, and this is quite tiresome, and yeah, I somehow would need to manage to stay sane editing all these presets. So I wished I had something like default value, something like inheritance of properties, and maybe a simple syntax. And yeah, then I thought, and that was actually 4 days ago something, I had drunk some beer and I sat there coding. So I thought maybe, yeah, there is CSS-conf tomorrow, right? So, let's see what we can do with CSS. And it turned out this is actually quite simple. So I can just use the rework parser, which gives me an AST of the CSS, and it doesn't care about whether these properties are understood by a browser or not, which is pretty nice. So I can just define properties that are basically they are the same properties of the devices and of the device groups. So I can just use them, and by just applying all these properties in reverse order of specificity, I end up with a really proper computed style which respects specificity and all that. So, yeah. And finally, I thought, well, I had this code mirror editor here, and so maybe, yeah, SCSS works, of course, so I could just compile SCSS to CSS, and then I can throw that at this lighting engine and see what happens. So, I have this editor here, which now, if I push save, it will hopefully, no, doesn't. Oh, wait. I probably would need to stop that first. Better. All right. So, we have now something that you could really work with. I mean, I have this extend statements here that import some pan and tilt settings for the spotlight, so I can just edit them and they switch back, or maybe back to the mirror ball. I can just edit these colors here. Where are they? Maybe we want to have this a little bit brighter, so let's say yellow. And I have another preset that wrote just an hour ago or something, so we can also do this, and yeah, wonderful. I wish I would be able to do a whole light show with it, but I guess this will still take some time, and the people from the venue will pick it up from here. So, final thoughts. What's next? This is actually, I think that idea is not bad, and I could probably wire it up with my home, so that I can write some CSS for our living room or something. Then one thing that was definitely missing are transitions and animations. So yeah, they could be added too. And this is, yeah, that's basically it. And I want to thank you all so much for being an awesome community. And yeah, just for having me. Thank you. And now...